Let's work on simplifying square roots. When we simplify square roots, we like the number inside of the root to be as small as possible. Here's an example. Simplify each radical. A radical, by the way, is just the proper name for a root or a square root, as I've mentioned up here. Square root of 12. You're going to have to break up 12 into two numbers. One of those numbers has to have a perfect square. So let's write down what the perfect squares are. The perfect squares are the numbers that have a nice square root. And here's how I can obtain the list. I take 1 squared, that gives me 1, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, and so on and so forth. This is the list of the perfect squares that exist. So look at 12 and figure out which of these divides into 12. And of course, that would be a 4. So I'm going to break up the 12 into root 4 times root 3. 3 times 4 is 12. Do the same thing with 27. Look at this list and see what's the biggest number that divides into 27. And that would be a 9. So square root 9, square root 3. Square root of 4 is a nice number. I'm looking for a number that I can multiply by itself to give me a 4. That number is a 2. Square root of 9, also a nice number. A number that I can multiply by itself to give me a 9, that number would be 3. This is why this list is good to have on paper. So on a test, you should, or even on a quiz, you should write this list down, and then it's easy to just look at it on paper. Now I add these. Imagine if I told you 2 cookies plus 3 cookies. You would tell me 5 cookies. Same idea with the radicals. 2 square root 3's plus 3 square root 3's is 5 square root 3. That's how we do it. Next example. You can pause the video and think about how to break up square root of 50. Look at this list. Try to do it yourself. Try to pick the biggest number that divides into 50. Okay, so when you're ready, you should have 25 and 2. Pause the video again and try to do it with 128. If you need a calculator, you can use one at this point. See if you can come up with the biggest number that goes into 128 from the list of perfect squares. That number would be 64. 64 times 2 gives you 128. Now I simplify. I have this 4 at the front. I leave that there. Square root of 25. A number times itself gives you 25. That's a 5. Square root of 64. I'm looking for a number that I can multiply by itself to give me 64. That number is an 8. So I have these. Now I have 20 square root 2 minus 24 square root 2. Okay, if I had like 20x minus 24x, imagine that. You would hopefully tell me that's negative 4x. That's the idea I want to use here. 20 square root 2 minus 24 square root 2 is going to be negative 4 square root 2. Okay. Next, we're going to look at multiplying radicals. When you're multiplying radicals, try to simplify each radical before you multiply them. In this example, I can't do that. There's nothing for me to do to reduce a 6. 6 doesn't divide by any of these perfect square numbers. Same thing with a 3. So my only option is to just multiply them together and get square root of 18. Once I get to square root 18, though, I can start breaking the 18 down into 2 parts. Think about which of these, pause the video, try to break up 18 using a number from this list, and then a different number, so we can have a nice root on the perfect square part. Square root of 18, you could do square root 9, square root 2. Square root of 9 is a 3. So 3 square root 2 is the simplified form of this answer. Pause the video, try to simplify the root 20. Break up root 20 into 2 pieces. And you can't do that with 14. Okay, I'm just letting you know ahead. 14 doesn't break down any further. But try to break up square root 15 into 2 numbers. One of them has to be from this list. Okay, so the numbers are going to be 4 and 5. Square root of 4 is 2. So you have negative 2 root 5 multiplied by 3 root 14. When I multiply these radicals, I multiply what's on the outside. I take the negative 2, multiply that by the 3. That's going to give me negative 6. And then I multiply inside of the root. I multiply the 5 and the 14. I multiply those together, and I'm going to have root 70. But 70 is not divisible by any of the numbers that are from the perfect square list. So this is as far as I can go. The answer is just going to be negative 6 times root 70.